Good day, students. Once again, this is another question on contingency table. This is in our contingency table again. And this question is quite tricky, to be honest, because it combines ratios and contingency table numbers. So it says 1/5 of the light switches produced by a certain factory are defective. So now, if there are those that are defective, meaning they have production problem, then meaning there will be those that are non-defective. So now this is something to take into account of the category. And it says 4/5 of the defective switches are rejected. So meaning there are those that are rejected. Remember, we produce these light switches with the intention to sell. So if it says others are rejected, it means others are sold. Remember, when you speak of the rejection in this case, meaning when you sell to the customer says, no, I don't want this light switch. So they reject them. So now, meaning if there are those that are rejected by customers when you sell them, meaning there are those that are not rejected, meaning there are those that are sold. So now another two category to take into account. So now let us just try to draw our table from the information that we are provided. Meaning now we have this two that are defective. We have these two that are defective. We have those that are non-defective. Then we can draw the line and say there are those that were rejected and there are those that were sold. Because if the customer does not reject a product, that means that product will be sold. So now this, then in the last column, we know that we have the total and the total in the last column. And I always don't draw this very formally, but it's very easy to draw. Then you draw your lines and you are done. Always like this when you draw a contingent table. So now, we are told that some of the light bulbs are defective. Let us go there. They are telling us that some of these light switches, they are defective. They said 1/5 of the light switches, remember 1/5 is 1 over x of 1/5 of the light switches. Remember, x represents the number of these switches. 1/5 of the light switches produced by certain company or factory are defective. So now 1/5 of these are defective. So let us write it under total. There is what is called defective. 1/5 of these are defective. So we'll say 1/5, 1/5x of these are defective. Remember, a total of this must give us 100%. Want to make sure that is 100%. But we are not dealing with a percentage, but we are dealing with a fraction. So 100% of the fraction will be 1. How is that possible? It will be 1/5 plus 4/5. This will give us 1, meaning if 1/5 are defective, the rest of them are non-defective, meaning they are not defective. Meaning now, in this case, it will be 4/5 of the rest are non-defective, so that the total is a whole number of 100%. And once again, coming back to the calculation that I've shown you before, that will mean now, for us to do a simplification, we take the lowest common denominator as 5. If the bases are the same, you keep the base, you end your numerators. So now we can just say 4 plus 1 will give us 5. 5/5 is equal to 1, and 1 is 100%. Remember, 100% is 100 over 100, and 100 over 100 is equal to 1. So now the whole total of the switches that we produce, they are out of 100%. So now this is what we have so far. We are told that 1/5 of them are defective. Therefore, now 4/5 of them are non-defective, meaning they are not defective. They have no production issue. They were produced very well at the quality that the company wanted them to produce. Then now we go to the second part of the sentence and we read. And I want to highlight the fact that I was not given this information. I had to know that my total has to be 1 at the end because I'm dealing with fractions. Remember, if it was percentages, this will have to be 100%. But in the case of the ratio, then we deal with, it will be 1 at the end of the total, indicating 100%. So I was not given this. I had to discover it myself. Very important also to know that. Then let us go and read what else is given. They are telling us that 4/5 of the defective switches are rejected. Let us look. 4/5 we have defective total. 4/5 of these switches, they are rejected, meaning 4/5 of these switches, they are rejected. So now 4/5 of these switches are rejected. Remember, I want to put this in numbers now. We have they say 1/5 of the defective switches. They don't say anything. They say 4/5 of the defective switches. Where are the defective switches? The defective switches are 1/5. So now they say 4/5, meaning of the defective switches are rejected. 4/5 of the defective, remember the defective switches is 1/5. X is representing the number of the switches. So now 4/5 of the defective, meaning 4/5 of the defective switches. And we know that of means multiplication, meaning 4/5 multiplied by those that are defective, which is 1/5, are rejected. So now it will be 1 times 4 times, in other words, 4 times 1, it will give us 4. 5 times 5, this will give us 25, and we put X indicating the number of the bulbs that were rejected and defective and rejected. So now this will be 4/25X. Now immediately when you have the 4/25 of those switches that are rejected, of the switches that are rejected and defective, then we can calculate what is missing here. Remember, we do have the total. We say the total minus the rejected, so that we get to know those that were sold. So now the total, which is the bigger number, 1/5X minus 4/25, it will give us the ones that were sold. Then now we continue on that. We look for the lowest common denominator. And to say in this case 25 is the number that 25 will fit and 5 will fit. 5 goes to 25. 5 times 1, it is 5. Then we say 25 goes to 25 once. 1 times 4, it will give us 4. Then we say minus 4. Then we continue, equals 5 minus 4, it will give us 1/25X. That means here those that are defective and sold, it will be 1/25X. Remember, 4/5 plus 1/25 should give us 1/5. How will that happen? Remember, when bases are the same, we keep the base and we add the indices or the numerators. That means you can just throw the line and you say 25. 4 plus 5, it will give us 5. 5 goes to 5 once to 25 5 times. The final answer is 1/5X, exactly as the total it appears. So now we have captured that part. Then let us read the next information now, because we are then again limited on what else next to do. And again now they told us for those that were rejected, So now they did not tell us about those that were sold, but we had to calculate those that were sold. Well, we said the total minus those that are rejected, then the rest will be those that were sold. Then let us read the next information that is provided to us. It says, and 1/20th of the non-defective switches. Let us look at the non-defective first. Do we have non-defective? We do have non-defective. We calculated it by our own selves, and now they do need that information. They say now 1/20th of the non-defective. What is the story about them? 1/20th of the non-defective switches are rejected by mistake. Either they are rejected by mistake or not, at the end of the day, they are rejected. So now it means they are rejected, either by mistake or not by mistake. At the end of the day, they are rejected. That's what is important. So now we don't need to have another column that says rejected by mistake, because something that is rejected, it is rejected, either by mistake or not by mistake. At the end of the day, it still remains rejected. So they said 1/20th of the non-defective, meaning 1/20th of the 4/5 of the 4/5 is rejected by mistake, which is still rejected. So now again, this is multiplication that is to take place. We have to multiply here. 1 times 4, it will give us 4. 25 times by 5. We say 25 times by 5, it will be 125. Then we have 4/125. So now let us look at that 1/20th, not 1/25th, 1/20th. It is 1/20th times by 4/5. So it will be 4/20 times by 5 will give us 100. So 4 does go to 4 once. To 100, it goes 25 times. So now we'll have 1/25x. I just made a mistake there. Instead of 20th, I said 25th. So now that means they said 1/20th of the defective ones, meaning of the 4/5, they are rejected by mistake, meaning they are rejected. That does not change. We just cross multiply. At the same time, you can simplify it further by saying 4 goes to 4 once, 4 goes to 20, it goes 5 times. Yes, 1 times 1 will be 1. 5 times 5 is 25. So you could have said that 1/25 immediately, without having to multiply and get to 4/100. Then after you simplify further, you could have said that immediately on spot. That was going to be 1/25x. So now of these ones, they are telling us that 1/20th was rejected by mistake, which in this case it is the 1/25x that was rejected by mistake. That means here 4 plus, it will be 5 here over 25, and 5/25 will give us 1/5x. I hope you see what I've just done. Remember, when the bases are the same, you keep the base and you just add the indices. Keep the base and you add the indices. That means what I've done here, I've just added the 2 because my bases are the same. So now what I've done, I could have just said 25, and it would have been like this. Just wait before. This is 4/25 plus 1/25, which is equal to the lowest common is 25. 25 goes to 25 once. 1 times 4, it is 4. 25 to 25 once. 1 times 1, it is 1, which is 5/25. 5 goes to 5 once to 25. 5 times, the answer is 1/5x. So that is where the 1/5x is coming from. 1 over 5x. So now we have sorted that one out. It is done and dusted. Then we go to the other missing cells, and at this stage now we can just subtract to get to the missing cells. Now we have the total here, which is the total minus rejected. We get to how much is sold. Very easy. Total, which is 4 over 5x minus 1 over 25x, and in this case the lowest common multiple will be 25, because 5 fit to 25 and 25 fit to 5 and also 5 fit to 25. 5 goes to 25, it will be 5 times. Then you say 5 times by 4, it will give us 16. Or 5 by 4, it will give us 20, not 4 by 4. 5 times 5 will give us 20. Remember, 5 goes to 25 5 times. 5 times 4 will give us 20. Then after we keep the sign as minus, 25 goes to 25 once. 1 times 1, it will be 1. That means we'll have 1 here, and our final answer will be 19 over 25. So now we have 19 here over 25x. Those that are non-defective and they are sold. We need to test again if our answers they gave us the same total. How do we test? Defective and rejected plus defective and sold must give us the total of 4 over 5, meaning 1 over 25 plus 19 over 25, it should give us 4 over 5. Let's just see if that will give us that. We are proving the equation now. Remember, when the bases are the same, we keep the base, we just add the indices. So now we keep our bases 25 and say 1 plus 19, it will give us 20. And we say this must be equal to 4 over 5. Then now we continue at this side. And we say now there is a number that fits to 20 and 25. 5 does go here. How many times? 4 times, and 5 goes to 25 5 times, and our final answer becomes 4 over 5. Exactly that 4 over 5. So now make sure that everything ties up together when we are done at the end. All your cells in the middle must be equal to your totals at the end. Now what are we looking for? We have to look for this one. How do we do it? You can say 1 minus that won't be a problem, but I don't want 1. We can say 1 over 25, meaning this cell, those that are sold and defective, plus 19 over 25. We can put the x there to indicate the number. It has to give us the total of those that are sold defective and those that are sold and they were non-defective. So now it will be again 25 and 25 will give us 1 base of 25. 19 plus 1 will give us 20, and 5 goes to 20 4 times to 25 5 times. You can see that it is 4 over 5x. So now here we have 4 over 5x. 1 over 5x plus 4 over 5x must give us 1. 1 over 5x plus 4 over 5x must give us 1, which is this total. Then after, how do we do that? We say our bases are the same. We keep the base as is. We just add what is above. You remember, when you say add, it means if it's minus, we minus. It does not mean always we add. We use the sign that we have. If it was minus, it will be minus. In this case, it is add. Then we'll add our indices in this case. So now our sign is a plus because we are adding those that are rejected in total and those that are sold in total to give us the total of our light switches. So 4 plus 1 will give us 5. 5 over 5 is equal to 1, and exactly that becomes 100%. What was the requirement? It's very important to answer the question in our contingency table. They say if all the switches not rejected are sold, what the percentage of the switches sold by phase 3 are defective? The percentage of the light switches that are sold by phase 3 are defective. Let us look at that. Those that are sold and they are defective, that will be 1/25. Those that are sold and are defective, that is the answer that they were looking for. And definitely you'll get your 1 mark there by responding to the question. Next time you can be asked any missing cell. You can be asked any missing cell. And the minute now you answer what is required, you don't have to be completing all these cells, and these cells might not have been necessary. But for the sake of a comprehensive understanding, you'll have to calculate all of them because you don't know how your assessment will look like for the next test. Otherwise, guys, thank you very much. That's clear there. We have 19/25 here, 19/25x, and here we have 4/5x. So yeah, this is our contingency table, and there's still another one that is coming after this one that I'll record for you guys. Thank you very much. God be with you.